Hello, everyone. It's a pleasure to be here and introduce young scientists and their innovative research. This is the Light Talk Session B, and I'm an assistant professor. I'm Elena Colicino, an assistant professor in the Department of Environmental Medicine and Public Health at the Icahn School of Medicine. And I will moderate this session with Dr. Calza, who is a full professor in statistics at the University of Brescia. So let's wait a couple of, or maybe a minute, so people can join us. Dr. Calza, do you want to introduce yourself in the meanwhile?
Hi, everybody. Well, I think Elena said it all. I am, she said I'm a full professor, actually, medical statistics at the University of Brescia. We like to point it out. And I'll say hi to everybody, and I'm really glad to be here helping Elena moderating this session. And good luck to all the presenters, by the way.
Okay, sounds good. I think we can start with the presentations. So basically, it's a lightning talks, and it's a lightning talk section, and we will have a short presentation. And after each presenter, we can ask questions. So feel free to type your questions in the chat, and we convey it for you. The first presenter is Mira Flasch, who is a PhD student at the University of Vienna, Austria, and she will present a talk which is titled Comparing Sensitivity and Low and High Resolution Mass Spectrometry for Xenobiotic Trace Analysis. Mira, the stage is yours.
Thank you for a nice introduction. So yeah, I will talk about the comparison of sensitivity of a low and high resolution mass spectrometry approach for the trace analysis of xenobiotics, which was conducted at the University of Vienna. As you probably all know, the exposome consists of a wide variety of chemicals which are structurally quite different. And common targeted low resolution approaches usually just cover a really limited number of compounds, which are often structurally quite similar. That means that emerging toxins or just some contaminants which aren't expected to be in the samples are overlooked. With the introduction of high-resolution mass spectrometry, it was hoped that this problem could be overcome and new unknown xenobiotics could be discovered. But the problem is that most environmental contaminants are quite low abundant, meaning that for their analysis, you need a quite high sensitivity to really detect them. And what we were doing was to determine the method detection limits of two different approaches. So on the one hand, we had a low resolution mass spectrometry, in particular our size Q-trap 6500 plus, which we were operating in multiple reaction monitoring. And on the other hand, a high resolution mass spectrometer, namely a Q-executive HF. Where we measured in full scan mode with polarity switching. For both of their approaches, we used the same column and the same element, and yes. And here you can see the results. So we measured about over 100 xenobiotics, but here I just showing you 40 of them to still keep an overview. And what you can see at first sight is that Q-executive in blue has way higher detection limits than the Q-trap in red. In the lower graphs, you see the results in a logarithmic scale to maybe visualize it better. And the average LOD for the targeted instrument, so the Q-trap, was around 0.029 nanogram per milliliter, whereas for the Q executive, we had an average LOD of 0.25 nanogram per milliliter. That means the Q-trap was about 10 times less sensitive than the Q executive. But for some chemicals, the difference was even higher, meaning that the Q-trap performed around up to 100 times better than the Q executive. So to sum it up, with the tailored targeted approach, we had detection limits which were 10 times lower than with the untargeted screening method. But for some chemicals, especially some pesticides and phytoestrogens, this difference was even higher. And this gap in sensitivity, of course, can hamper the discovery of low concentrated environmental chemicals while untargeted measurements. So thank you for your attention. And here you can see an overview of my slides, and I'm happy to answer any questions you might have.
Thank you so much, Mira, for your short presentation. I actually have a question related to the samples that you use. I actually probably missed that. What kind of sample did you use? It was plasma, it was serum, it was blood, it was any specific tissue. And do you think that do you think that there is any tissue specificity about those limit of detection?
Well, so in this case, I compared urine samples, and I didn't check any other matrix, but of course, I think that the matrix has an impact because also depending on the sample preparation, the drawback of the targeted approach is for sure that I have a higher background noise, and that's of course matrix dependent, I think.
I see. Thank you so much. Anyone with, do you have any other questions for Mira? We can please.
Sorry, Elena, I just have a quick question. Hi, my name is Doug Walker. I'm an assistant professor at Mount Sinai. That was a fantastic talk. I just have a question about the comparison between the methods. So was your low resolution method, specifically optimized for quantifying these compounds, or was it just kind of a generic method that you applied, to test these detection limits?
It was optimized for xenoestrogens. I think in the method, you're gonna hear more about the method in the next talk, but I think it included about 80 xenobiotics, and it was optimized for them. So it was not a generic approach.
Great. Thank you so much, Mira.
You're welcome.
So I guess we can move on and have the next speaker, who's Thomas Yamnick, who's a research scientist at the Department of Food Chemistry and Toxicology at the University of Vienna, Austria. And his talk is going to be on assessing multi-xenobiotic exposure in plasma of extremely premature babies by a new LC-MS approach. So Thomas, you're on.
Thank you. So I'm from the same research group as Mira just before, and I'll now talk to you about the xenobiotics we found in the plasma of extremely prematurely born babies. So this is the method that Mira was just talking about. That is our targeted multi-xenobiotics method. And the background here is, we were searching the literature, and whenever it was about biomonitoring methods for different environmental contaminants, people always seem to focus or at least produce tailor-made methods for single classes of either synthetic or natural compounds. So we just figured, why not try to assess multiple classes of synthetic and natural compounds in one method, because that would be a lot less work in future applications. And we were, in our opinion, somewhat successful. I included 81 compounds in our multi-xenobiotics method, and here I just classed them in 4 categories. We've got natural xenobiotics, mostly associated or main routes of exposure are just food, and different classes of synthetic xenobiotics. We all know by now about perfluorinated alkylated substances. Some polycyclic aromatic hydrocarbons are included just as a marker of smoke exposure. Of course, plastic components, BPA, phthalates, and personal care product ingredients like parabens. And a main focus was on, endocrine disrupting chemicals. However, if we look at the natural side of things, there's quite a lot of genotoxic food constituents included as well. And this method, 81 compounds, we routinely reach levels in sensitivities down to the picogram per milliliter range, which is parts per trillion. And this method is actually applicable to urine, serum, and breast milk samples because we validated it for all of those matrices. And first proof of principle was the application to a cohort of 21 extremely prematurely born infants. Samples were provided by the Medical University of Vienna at day 28 after birth. And, our sample preparation scheme is quite generic and fast: a simple liquid extraction followed by a protein precipitation and a targeted analysis using our Q-trap. And we were able to detect 27 xenobiotics in those babies, among those babies, 5 of natural origin and the rest of synthetic origin. And, we've got some suspected sources of exposure here: breast milk, the donated breast milk that was used to feed the babies, the contact with, plastic medical equipment in the intensive care unit, drug formulations usually include some parabens and so on. So sources are quite of a wide variety here.
Thomas, sorry for the interruption. Can you give your presentation in the presentation mode?
I am doing that right here in my screen.
Okay.
I don't understand why you can see it.
It's okay. I'm just saying it's okay. Thank you so much for trying.
No, that's funny because I'm seeing the presentation, but I think it should suffice.
I've had this happen during my dissertation. You might be sharing a different screen to Zoom than you are seeing.
Yeah, I'll just do this one slide and we can zoom in whenever you've got questions.
Okay, great. Thank you.
So I'm sorry. So these are 9 xenobiotics that were detected in all baby samples. And here we can see the quite prominent perfluorinated substances, PFOS and PFOA, a polycyclic aromatic hydrocarbon, different parabens. I think I detected 6 or 7 in general, and phthalates and BPA plastic components. And just looking at PFOS and PFOA levels, they are quite worrisome in some cases, but for the remaining compounds, we cannot really yet effectively judge the implications here because we don't really have the data concerning, co-exposures in a given concentration range. And for that reason, we want to apply this method in larger cohorts in the future to really get a better idea of the, to link the internal dose with external or with the resulting health implications. And that is already a main, can you see? Okay, yeah, now I'm already done. And the main takeaway here is you can develop generic methods to assess, a multitude of different classes of synthetic and natural chemicals at trace levels of sensitivity. We encourage the systemic introduction and expansion of such methods in, routine analysis. And our premature baby cohort is already, although they are quite young and haven't been, around that long, already heavily contaminated with some synthetic compounds such as BPA, phthalates, parabens, and perfluorinated alkylated substances. And with that, I am done, and I thank you for your attention, and I thank my research group.
Thank you, Thomas. Very nice talk. Any questions from the audience?
Hey, Thomas, that was an excellent presentation. So I have a few questions just about the methodology and what's being measured. So, you mentioned the ability of using this assay to characterize blood, breast milk, and urine. But you're going to be detecting different forms in different components. Like in urine, you'll have the conjugates, but you may not necessarily see those in serum. So my first question is about whether you alter the sample prep prior to the assay, depending on the matrix. And my second question is, you had phthalates and BPA and parabens that you were detecting in blood, but those tend to be best measured in urine, and we tend to see extremely low levels in blood samples. Do you think those measurements are kind of unique to the cord blood, or kind of, do you have any ideas about why some of the levels were so high, especially for dibutyl phthalate?
So the first question, the sample prep, it is different for, it's the same for urine and serum, but for breast milk, because of the high protein content and lipid content, the extraction solvent is a little bit different. It's a two-phase extraction because the breast milk sample is, the breast milk matrix has a lot of interferences, so we need to get rid of that. But we do not in this, so for the data I'm presenting here, we did not include an enzymatic deconjugation step. We did measurements of urine with and without enzymatic deconjugation. We measured breast milk, and we can detect chemicals with or without enzymatic deconjugation in urine. And we, of course, detect different chemicals in breast milk because it's more hydrophilic. And yeah, it's just the main challenge here was to create a generic extraction scheme that works for such a wide variety of structurally very different chemicals. And but we do not need an enzymatic deconjugation for urine samples. Well, I mean, you have to add that it's a different kind of analysis, right? If you want to look at the whole chemical load, so to speak, of course, if you deconjugate the urine, you will detect more chemicals. But maybe there isn't really much data out there concerning that. Maybe it has different implications if there's more non-deconjugated forms in the urine compared to if almost everything is conjugated. And I think our research group will do some more research in this concerning that subject in the future. And if that's a good answer to your question. And the second question was BPA, parabens, and so on. Yeah, usually those are assessed in urine. That's true. And we just, which is why I had troubles finding, comparable levels concerning the baby cohort. However, we did measure some adult control samples as well. And you are very much right that the concentrations in the adult control samples of parabens and BPA and phthalates were much lower. And we have, as I've said before, we've got some, we suspect some sources. Those babies are, to the best of my knowledge, are or have been at the time in quite a critical condition. And, they're in the neonatal intensive care unit, and there's tons of different instruments used on them, feeding tubes and so on. And we suspect that those are a main source of phthalate and BPA contamination. And for the parabens, as you can see in the plots here, for a few single babies, concentrations were very high. And the only thing that we could think of up until this point was different drug formulations that use parabens as, I think, preservatives, if I'm not mistaken. And for PFOS and PFOA, that's quite interesting because those levels are very high. And that should not be the case. at this point in time because the babies they haven't had much time to accumulate those chemicals, but levels for some of them are still very high. So yeah, we are quite interested in the implications of that in the future if we have more data.
Thank you, Thomas, for this nice presentation. I think we can ask more questions to Thomas at the end of all presentations, so everybody can have the opportunity to speak about their research. So let's move now to the next presenter, who is Jay Kitt. He's a postdoctoral researcher at the University of Utah, and Dr. Kitt will present on the informatics-based investigation of the link between air pollution, sleep apnea, and underlying pulmonary disorders.
Thanks for the introduction and thanks for having me. Can everybody see my screen all right?
Yes, we can see it clearly. Thanks.
Okay, cool. Yeah, so I'm going to talk about some work that we've been doing here at the University of Utah, looking at the links between air pollution and sleep apnea, and then kind of the underlying conditions that might lead to these links that we have uncovered. First question is, what is sleep apnea? It's a sleep disorder where there's pauses in breathing during sleep. Obstructive sleep apnea tends to be the most common one. Obstructive sleep apnea is where your airway actually collapses for periods of time, and it results in periods where you're not breathing well. And they can be either apnea events, full apnea events that close your airway completely, or hypopnea events. Those are events where your airway is just mostly closed and you're having a little bit harder time breathing. Why are we worried about sleep apnea? Sleep apnea impacts your whole body. It increases risk of things like stroke and heart disease, increases risk of depression and anxiety, and a number of other things. It impacts between 1% to 6% of adults and 2% of children. The actual underlying cause is unknown, but there's a lot of contributors. I've highlighted 3 of them here, reflux disease, allergies, and smoking. And the reason that I've highlighted those is because they are associated with inflammation. And the hypothesis as to why inflammation leads to more apnea events is that in your normal airway, collapsing the airway is a little bit tougher than if you actually constrict the airway, where you have a smaller energy barrier to actually closing that airway and having an apnea event. So our hypothesis was that air pollution could contribute to this as well. And air pollutants, including all of the ones listed here, particulate matter, sulfur dioxide, nitrogen oxides, and ozone, are all associated with airway inflammation in different conditions. So again, the hypothesis is that sleep apnea is going to be negatively impacted by poor air quality. How are we going to study it? Typically, people, when they're conducting studies on sleep apnea, they will do full-on sleep studies where they'll bring a patient into the clinic and actually study what's going on with them in the clinic, hook them up to a bunch of devices and monitor. But this is challenging when you're trying to look at something like how air quality impacts sleep apnea, because air quality is a little bit harder to predict when it's going to be bad or good. And even if you can know that tomorrow is going to be a bad air quality day, you still need to have a patient that's willing to come in kind of on call and be studied on that particular day. So we got working with this company called Respironics that builds CPAP devices. These are continuous positive airway pressure devices that apply pressure to the airway to keep the airway open during the night. And they're the main treatment method for sleep apnea. And just like every device that we own nowadays, these things collect data and they store data on a cloud. And usually that data is used for the practitioner to be able to make adjustments to the device, but we figured maybe we could actually use that information to study how air quality impacts apnea. So we had data from a whole bunch of patients over 10 years, and we combined that with daily measures of air quality in the location where those patients were. In this case, it was the Salt Lake Valley. And over 10 years, on combining both of these data sets, we had just under 1 million patient days to work with to try to see what we could find. And I'm kind of going to skip over a lot of the details, but one of the things that we did kind of early on was to try to predict when the population was generally going to have bad days. And a bad day in this case would say that better than 10% of the patients were going to have higher than their average number of apnea events. So that's to say 2 standard deviations above the mean for an individual. There's going to be better than like 150 patients on a given day. So when we did that, we found that there's about 90,000 patient days that matched that. And if we use a random forest algorithm to try to predict when those days are going to happen, we can do it quite well. We can predict with about 95% accuracy. And one of the cool things about random forest algorithm is that it provides you the coefficient weights, which can tell you something about which of the pollutants is going to have the greatest impact. And in this case, you can see that PM 2.5 seems to be the one that is impacting people the most. We thought that was pretty cool, but we wondered a lot about what underlies this prediction and what might be the comorbidities that lead to it. And so we linked that patient data with those patients' ICD codes for their visits to the University of Utah hospitals and clinics across this entire period of time. For that data, we had about 1,600 patients that matched and close to 40,000 visits. And if you combine that data and have a look at it, what you find is that the very most compelling result is that patients that have asthma and sleep apnea tend to be the most sensitive, and what they are most sensitive to is PM 2.5. So that was just kind of an interesting result. It tells us a little something about what might be underlying these patients having worse time with sleep apnea when there's air pollution. So with that, I'd like to thank my research group advisors, and thank you for listening. I'll take any questions.
Thank you so much. Thank you so much, Jay, for this nice presentation. I actually have a question related to your results. Do you see any sex differences in your results? I assume that the prevalence is different in between men and women.
Yeah, you do see some differences, especially when you start looking at underlying conditions. So asthma was the most obvious one, but COPD is also one that is impacted by air quality. And so you see differences there because more men smoke than women. And we also did some analysis of like socioeconomic kind of stuff, where you'll see that the Salt Lake Valley is pretty divided in economic status. And on one side of the valley, you see that people are generally worse off than on the other. So that was kind of interesting as well.
Thank you. Any other questions for Dr. Kit?
Yes, I have a question.
Sure.
Hi, my name is Mayan. Thanks a lot. It was very interesting. If I understood correctly, you were able to assess the association between air pollution and events of sleep apnea among those who are already diagnosed. Do you have data to try and test for associations with disease occurrence compared to those who didn't have sleep apnea?
No, I mean, it's hard to study patients that don't have sleep apnea using this particular method because we're using CPAP device data, so it's data that comes from patients that have been diagnosed.
Hi, Jay. This is. Can people hear me?
Yeah.
Yeah, it's kind of a follow-up question. You mentioned for your patients, how do the patients themselves? I know this is different, but can you give a little bit more of can you describe them a little bit more and how do they compare probably to either maybe the general patient population or maybe the total population that's representative of perhaps your patients?
I mean, I guess I'm not sure what you're after. They're generally older. The split between men and women is not particularly high. Getting race demographics is a challenge in Utah because our population is like 90% white. So I don't know, I guess exactly what you're looking for.
I suppose my question was mainly like how representative or not were those patients compared to the surrounding areas, I guess. So, but if you don't have the information, that's okay. I was just curious about it.
Yeah, I'm not positive. It's a good question and certainly something worth looking into.
Thank you, Jay, for your presentation.
Sure.
So we could move to the next speaker, who's Johanna Kunin, who's a postdoctoral researcher at the CONICET IDES UNSAM Argentina. And her talk would be on social risk perception and gender dynamics in pesticide-based agricultural production in the Argentine Pampas. So Johanna, the stage is yours.
Thank you, Stephanie, and hi everyone. Thank you for having me here. I feel I'm kind of an alien coming from social sciences, but very excited to be here today in order to engage in a kind of interdisciplinary dialogue about all this stuff. So women and men do not perceive dangers or risks in the same way, nor do they react to them in an identical manner. However, when it comes to the debate about pesticides in Argentina, few risk prevention campaigns and few studies have addressed the relationship between gender dynamics and risk perception. I have a PhD in social anthropology, and I am currently a postdoc. For the past 7 years, I've been conducting ethnographic fieldwork alongside rural workers in the Argentine Pampas. I want to know why women identify and denounce pesticide-related risks and why men tend to turn their backs on the problem. Let me first provide some context. Argentina is one of the world's biggest producers and exporters of genetically modified soybeans. GM soybeans are genetically engineered to resist glyphosate. In 2015, glyphosate was classified as probably carcinogenic to humans. The expansion of GM soy was encouraged by a surge in international prices, and today soybeans represent 1/4 of Argentine exports. Many financial, economic, environmental, and health-related issues are interwoven in the story I'm telling you today. Now, imagine that my name is Maria. I have no land of my own, and I have 4 school-aged children that live with me and my husband in the Argentine Pampas. My husband is a rural farmhand. We are given a salary and a house next to the fields where my husband works. I didn't finish high school, but I know food. I've noticed that every time the crop duster flies over, the lettuces in my kitchen garden shrivel up. Because of this, and because of the agroecology course I took at my children's high school, I decided to stop buying vegetables from the supermarket. I just give my kids what I grow myself to safeguard them. Now I am also growing to sell. I like being recognized in the community as someone who produces healthy food. It's a way of taking care of us all. Now, imagine my name is Pedro. I'm Maria's husband. I work sowing, harvesting, and spraying crops for a farmer. I've seen how animals sometimes get sick or die after drinking water where the sprayer truck is cleaned. I often have breathing problems and skin rashes, but the doctors, who are friends of my boss, say it's because I smoke a lot. Sometimes they give us protective suits and masks when we are spraying, but we never wear them. The guys say that only faggots wear those astronaut suits. Real men like us are afraid of nothing. Besides, if I put on those suits, I waste too much time. The boss tells me not to listen to my wife or her concerns. He says science has shown that pesticides are harmless. Besides, what else can I do? If I quit this job, my only option is to work in another field using the same pesticides. I'm Maria. Could my husband be poisoning the environment? Is my brother who works with him a murderer? I refuse to see them that way, as some ecologists argue. I'm Pedro. I believe my boss, but deep down I have my doubts. But I'm no chicken shit, and besides, my family has to eat. My way of taking care of them is to make sure we make ends meet. I'd sacrifice my own health to do that if necessary. I was taught to be a real man. Maria's and Pedro's stories are not uncommon. What I have found is that there's nothing innate in women that leads them to protect so-called nature. Nor do men destroy life by following their supposed instincts. No. The fact that women identify and denounce pesticide-related risks has to do with the social construction of femininities and the way care is socially organized around gender identities. Furthermore, I claim that there's a link between pesticide exposure and reformation of virility, that virility has implications for the practices involved in taking care of others. For men, care takes the form of breadwinning rather than taking care of health or the environment, which is the way women tend to relate to care. That virility is also linked to the absence of self-care practices among men. This is why public policies focused on risk communication and prevention need to be very clear about one thing. Our approach to risk is not gender neutral, as we saw with Maria and Pedro. Thanks for listening.
Thank you, Joanna. That was a really entertaining talk, I must say. So, anybody has any questions?
I actually have a small question. And do you think people can experience the same type of detrimental effects also in not in rural area or agriculture area, but also in cities?
You mean in terms of gender?
Yes.
Well, there's one main thing that is who is generally in charge of, for example, not only growing, but also buying food for households. And well, in Argentina, women, we are still mainly in charge of buying food. So even in cities, women are in charge of that. So they may tend to be a little bit more conscious about that, but this is not really a great debate in cities right now. Like only upper class population sometimes tend to think about organic food or ecology food, but it's not a real big debate in Argentina. I mean, it's kind of a taboo thing that we don't tend to speak about because it's so big for our economy that it's kind of an unspeakable topic.
Thank you so much. Also, this reminded me why I'm doing what I'm doing. And I think it's important to always keep in the back of our minds that we should do policies for everyone, especially for those that are more vulnerable. Any other question?
But you're a
Joanna?
woman. We saw that women are more.
I mean, I'm talking
Careful.
about people that maybe are not well educated, or maybe they cannot get access to a specific type of education, or they are more prone to be exposed to specific exposures. Saying so, I didn't want to say that women are more, maybe they are more sensitive as well. So.
Yeah, but I mean, what I claim is that they might be more aware of this issue, but not because of anything that is innate in sex or gender, but just because the division of sexual, I mean, what is related with care, and also, I mean, we tend to relate only with gender and women and care, but I also found that virility is something central, because this thing about, well, like in Italy or in Argentina as well, and in many other countries actually in the Western world, of men not being accused of being cowards, and cowards is protecting yourself from risks, and that exposes them as well. Not because they are stupid or because they don't care about the world, it's just that their virility is at stake whenever they try to protect themselves.
Thank you so much, Joanna. I think we are ready for our next speaker, who is Xiongwing Chang.
Yeah.
Thank you. Who is a postdoctoral fellow in our department at the Icahn School of Medicine at Mount Sinai, and she will speak about neighborhood characteristics associated with COVID-19 burden, the modifying effect of age. Thank you.
Thank you, Elena. So I'm Trainee from Mount Sinai. I apply an omics-style approach to study the association between neighborhood characteristics and COVID-19 burden in different ages. The COVID-19 data are the cumulative cases reported by Illinois Department of Public Health, which is publicly available, and they report the case by zip code in Illinois and by 8 age groups ranged from less than 20 to more than 80s. So the exposure are the neighborhood characteristics measured by American Community Survey. We usually call it census data. The census data is also available at the zip code level, and the data source I use have the more than 400 census variables measuring different characteristics of our zip code. So I just a little background about this type of study. Traditionally, when epidemiologists do this study, they pick up several census variables as a representative of our neighborhood's socioeconomic status. But since COVID is our new disease, I hypothesize that there are some neighborhood risk factors that has not been recognized by traditional epidemiology. So I use this approach. I started association between every census variable and the COVID-19 incidence in one age group. So I did both the pairwise analysis, which build individual linear regression models for each census variable and age group, and also do variable selection. I built our large linear regression model for all of the 400 census variable and used the lasso to select the variables that most highly associated with COVID-19 in age groups. So there's some results. This is a heat map, shows the correlation between census variable and the COVID-19 incidence. So in each row, the name is too little to show here. Each row is one of the 400 census variable, and the color shows the correlation between the census variable and the COVID-19 incidence in each age groups. So we can see from the color, the number and the strength of the association, correlation between the census wearable and COVID incidence getting stronger as the age goes up from children to young adults to adults and to seniors. And there are not a lot of census wearables that are related to the COVID-19 in seniors, which indicates that aging is still the most important risk factor of COVID infection. So based on those results, I draw some network graphs to show the association between census wearables and also shows the relationship among those census wearables. So by doing this, we can see some clusters of wearables contribute to COVID-19 incidence in each age groups. So for example, we can see the cluster of Hispanics, cluster of health insurance, or cluster of essential workers. Those wearables are highly associated with COVID-19 incidence in children, young adults, and adults. And as the age goes up, we see more wearables like more demographic wearables such as ancestry, and more wearables related to household informations. Those wearables in the graph of seniors. So by doing this, we can see different type of census wearables associated with different associated with COVID-19 incidence in different ages. So just some summary. I personally really like this approach. I know we can see that this approach can tell us something that traditional epidemiology cannot tell us. We can identify new risk factors, and the results are easy to visualize, so we can see the contrast between different study groups. And also there's some limitations that inherited from this open style approach, but I hope this approach can be more widely applied in social and ecological epidemiology. I think that's it.
Thank you so much for your nice talk. Anyone have a question for Dr. Chang?
I do. This is Gabriel from NCI. Hello, Xue-Ying. This is a wonderful talk. You know, you mentioned that the limitation is it doesn't have any hypotheses, but to me, it seems like maybe it doesn't have any a priori hypotheses, but it seems like it'd be very much generating a lot of hypotheses. So from all the results that you saw, I'm sure there are a lot, and from that one slide you showed about your results, do you have any ideas of what popped out? And I imagine that, and you kind of suggested it too, but I guess my question is, anything that you saw pop out, and what do you think is the next step to perhaps address certain characteristics that you saw?
I think all of the results are based on the results shows here are all based on the pairwise analysis, which is the linear model built based on individual association between the census wearable and the COVID-19. So the next step, I think, is a wearable selection. So when you have our overall understanding about which are the wearables that are highly associated with COVID, then you can do our more IP style analysis to put those models in the same model. So say the adjusted association between those wearables and the COVID-19 incidence.
Thank you.
I'm not sure if that answers your question.
I don't want to monopolize other people's time, but I'm sure I can follow up later. Hope if you have not had, I'd be curious to see about a paper later on. Thank you.
Thank you so much, Zhang Wei.
So we can go to the next speaker, who is going to be our last speaker, and he is Vishal Media, who's a postdoctoral fellow at the Department of Environmental Medicine and Public Health at the Icahn School of Medicine at Mount Sinai in the USA. And his talk is going to be on prenatal exposure to endocrine disrupting chemicals and liver injury in children. So Vishal.
Thank you for giving me the opportunity. Sorry, 1 second. Can you see my screen?
Yes, we can.
All right. I cannot somehow connect.
I could see your screen.
Okay, all right. Yes, yeah, it was not popping.
Now we can see.
No, okay.
Yeah.
Thank you so much. So today I'm going to talk about different endocrine disrupting chemicals and their associations with liver injury in children. So this work has been done in collaboration with USC, IS Global, and Mount Sinai. So the database is from the Helix network. I'll get to that. Okay. So the background, we want to study the endocrine disrupting chemicals and how it may increase or decrease liver injury. And that there are some studies obviously on this particular field, but the important part of this study is we have like multiple chemical groups in this particular case, and very few studies have done this association testing for multiple chemical groups. So that's one of the important things for this study. And what you want to do is here you want to find the associations between the prenatal exposure to the to a wide range of endocrine disrupting chemicals and liver injury. What's our data? So the data set comes from almost 1,000 children from different, like 6 different European cohorts. It comes from the Helix network. And in our data set, our exposures are 30 chemicals. So, and the distribution for those chemicals are given in like this. So we have 3 organochlorine pesticides, we have 5 PCBs, 2 PBDs, 10 phthalates, 6 phenols, and 4 organophosphate pesticides. And all of them were measured in the maternal blood or urine. And our outcome, since we're studying here the liver injury, it's the child serum liver enzymes, ALT, AST, and GGT, which are measured around like 8 years, when the child were around 8 years. And now this is the tricky part where we define the liver injury. How do we define it? As having any of the liver enzymes at more than 90th percentile. Now, obviously, the 90th percentile was chosen by us, and this has been published also in multiple publications by Helix, but that's debatable, obviously. But that's a good way to go for now. All right, next. So since we have multiple chemicals, we have almost 30 chemicals, and let's say our output, which is a binary output, one of the most important things are to select the variables, because there is no point of like looking at all the 30 ones. So we started with elastic net penalization regression, and then chose some of the variables. And then for individual chemicals, we did generalized Bayesian generalized mixed effect regression models. Now see, in all of these models are controlled by some of the confounders, for example, age, and then the other, like for example, the cohort, which cohort they're coming from, and multiple other things. So that's one part. The another part, which is very interesting, is how these particular chemical groups that I talked about here, like organochloride pesticides, PCBs, or phthalates, altogether, these mixtures contribute to the decrease or the increase of the liver injury. And if we can get any estimate of that. So there were like 3 parts of the analysis. One was the selection, one was single individual chemicals, and then one of the mixture of the chemicals. And then what do we get from the results? So I'll start with the mixture. I'll start from the bottom and then I'll go up. So the mixture analysis, which was very interesting, was the organochloride pesticides and the PCBs were associated with the increased odds of liver injury, and you can see the confidence intervals. Now, one of them are like statistically significant, the other one wasn't, but still like there is some indication there. And the other indication, which was kind of like baffling to us a little bit, which was the high molecular phthalates, there are actually decreased odds. The point estimate was the odds ratio was less than 1, though this methodology does not quantify it is as a null result, but probably it might be a null result, but this is the result for now. And for the individual chemical analysis, so in the mixture analysis, we see the associations with increased odds for the PCBs and the organonuclear pesticides. Also for the individual chemical analysis with the generalized mixed models, we get the similar direction. So that actually makes our analysis a bit stronger because both of these analyses comes from different, they're constructed in a different way. And even then we're getting some similar directions. So in this particular case, DDT and DHP were like significantly associated and they had the similar directions. And then, so that's about it. And so the results, basically, the conclusion is a small conclusion that some of these chemicals are associated with the child liver injury at age 8. Now, we want to eventually do some of the sensitivity analysis, like include the sex, also the chemicals for the children, which we're doing right now. But for now, this is the result we have. And I want to acknowledge my advisor, Dr. Damaskini Valvi, for her help and incisive insights. Please ask me any question if you want to. Thank you so much.
Thank you, Vishal. It was a nice talk.
Oh, sorry, my microphone was gone. So I was
Please
speaking.
go ahead, Stefano.
No, sorry, stupid me. So I was saying there is a question in the chat. So I'll ask Ryan to speak up if he wants to ask the question.
Hi, nice talk. I was just curious if some common influences of liver inflammation in children, for example, BMI, were considered in your analysis.
Yes, they were actually. So BMI was treated as a confounder for now, so, and it was added in that way. But also there might be some indications it might be modifying the effect. So yes, but it was not statistically significant, but still there were indications. So it was, yes.
Yeah, I mean, the next question was about BMI potentially exacerbating the effect, but I'm sure you're looking at that. Nice.
Right.
Thanks.
Thank you.
I have a very simple question. So I'm not familiar with liver disease. So when you say that liver disease is defined as having any liver enzyme above quantile,
I cannot hear
said,
you.
Can you hear me?
Yeah, now I hear you. Yeah.
Oh, okay. Oh, sorry. So I said you define the phenotype, the outcome as having liver injury, have any liver enzymes above some threshold. So I didn't quite get how you define the threshold. So is it 90th percentile of your sample, or it's coming from a reference?
90th percentile of the sample. There is no reference as such. There are some proposals in the literature about like having some cutoff that are there, but but also the fact that this sample, it might not be compatible with our sample. So so how we did this analysis, like we consider all the individual chemicals separately, but also we have this particular results where we have these three, there's a binary. So what I'm presenting to you is the binary result, but we also have the other, because this ALT, AST, and GGT, they're all continuous measures. We also have that. Now, obviously, what you asked is like a very nice question and entails an answer, which is a 98th percentile. It's for the sample, but not a population generalized one. No, it's not. But what we plan to do is we probably will change this play around a little bit with this particular cutoff and see how our results vary. Ideally, it should not vary too much, but if it varies, then probably this cutoff, something is wrong with this cutoff.
And are these children measured more than once? I mean, is these enzymes varying with the person? So also, I guess that also how long the enzymes is high expressed or high present might actually matter. It could be just one episode or.
Yeah, so we have a snapshot here. We have just a cross-sectional data for now.
Okay.
But yeah, that's a very nice point actually. It will obviously is going to change, and it's probably, if we have that data, then it will be a time varying coefficient data or something like that kind of model that we have to work on. But for now, we have a snapshot.
Okay.
Thank you so much, Vishal, for your nice talk.
Elena, I had a question. Could I ask my question?
Yes,
Yeah, go ahead.
if it's
Sorry, I had my
brief.
hand up. Vishal, I had a question about the phthalates.
Yes.
I was wondering if you could tell us the parts, the concentration, because I'm wondering if your phthalates result, the fact that you were surprised by the effect has something to do with the fact that phthalates often have a bimodal distribution, so very low concentration, very high concentration. So was it that the distribution was so wide in this group, or was there maybe some?
It was a little skewed distribution, but we did not actually find. I mean, this was actually asked by someone else also before. Somehow it did not have a bimodal distribution in this particular case, but you are right. It do have. Usually they do have, but this was more like a skewed distribution, and since we are doing a log transformation eventually, it was like taken care of. So yeah, to answer your question, the distribution was a little skewed, but not like a normal distribution as such, but not bimodal.
Okay, thank you.
Thank you.
Thank you so much for the talk and the questions, and to participate at this lightning talk session. Actually, I'm very, very grateful for this technology, the Zoom technology that has helped us to organize and attend this meeting. And I hope this technology can be also helpful in reducing disparity and to let us hear more voices in future meetings. This is actually is our last event of the day, and this is the last session of the day, and we can return to the webcast tomorrow at 8:30 Eastern time, or otherwise at 2:30 Central European time. And I'm happy that everybody can attend the talks today, and see you tomorrow. Have a great afternoon or evening.
Thank you.